Hey everyone, welcome back to another video by Camroom 5. After talking about some of the addition reaction for alkenes, we're going to talk about another addition reaction, which is the addition of hydrogen, and this definition is applied to alkenes only. It is also known as the reaction of hydrogenation. We should again define the definition, like the word addition. Addition reaction means a reaction that produces no byproduct, that produces no byproducts. And obviously, the word hydrogen means that hydrogen is our reactant over here. In order to understand the hydrogenation or the addition of hydrogen, let's take an example of our molecule ethene, which is here on the left hand side. When ethene reacts with a hydrogen molecule, it's a very simple reaction where I should focus on these two carbon atoms. I should focus on the yellow one, and let's say I should focus on my blue one. Obviously, there are two carbons only, but it would become more important for us to highlight them if you're talking about more than two carbon chains. Your basic idea should be that you remove the carbon-carbon double bond and everything else remains the same. The yellow carbon still has two hydrogens, the blue carbon still has two hydrogens. But your reactant, which had two hydrogen atoms, both hydrogen atoms, like one atom attaches on one carbon each. And now you don't have ethene anymore, you have ethane. In the beginning, you were dealing with alkene, which was unsaturated compound, and now all of a sudden you have an alkane with you, which is a saturated compound. The condition for this reaction is high temperature, which is almost 200 degrees Celsius, and the catalyst of nickel. Let's take another example where we are dealing with propene. So on the left hand side, you can see propene just below ethene, which is a compound with three carbon atoms, carbon 1, 2, 3. You should understand that my focus should be on the yellow carbon, which is on the left side, and the blue one, which is in the middle. When I react this propene molecule with hydrogen gas in the presence of nickel catalyst and 200 degrees Celsius temperature, my compound almost remains the same with all three carbon atoms. There are still two hydrogen atoms on the yellow one. There is still one hydrogen on the blue one, which is the middle carbon, and the three hydrogens on the carbon of the right side still the same. So the point is that the carbon numbers are not changing, even the rest of the hydrogens aren't changing. But because you were dealing with hydrogen gas addition, you add one atom each on both carbons. So now you were dealing with propene, but now you have a propane molecule, which is a totally different homologous series of the alkanes. Propene had a molecular formula of C3H6, but after addition reaction, you have C3H8. You can see how the two of the H2 became added on the 6 of the propene. Let's do one more example where I'm dealing with butene, which is a 4 carbon alkene. It has a molecular formula of C4H8. If I deal with hydrogen addition, again, I should revise the conditions so that you just memorize it. 200 degrees Celsius temperature, nickel catalyst. Even if you write high temperature, that's okay. Remember, there are 4 carbons, carbon 1, 2, 3, 4. You should focus on the double bonded ones, which is carbon 1 and 2. Technically, the name is but1ene. I hope you already have watched my video on isomers and you know why am I calling it but1ene. I'm calling it but1ene because on carbon 1, you can say the double bond between carbon atoms begin on carbon 1. So the double bond is between carbon 1 and 2 and it begins on carbon 1. That is why we just call it but1ene. We could also have but2ene, but that's a different compound. An isomer, obviously. Now moving on, we have but1ene and I am now adding hydrogen. The 4 carbon atoms will still be in an unbranched manner. My yellow carbon and my blue carbon are still here. The yellow carbon still has two hydrogens, the blue one has one hydrogen, the other two carbons have their all hydrogens around them. You will add one hydrogen on carbon 1, you will add another hydrogen on carbon 2. The angles don't matter. They could be on left side or right side, they could be top or bottom, but you just draw one hydrogen on carbon 1 and another on carbon 2. That is your basic idea. So now you don't have butanene anymore, you have a simple butane, which has a molecular formula of C4H10. So at the end of the day, C4H8 reacted with H2 and gave you C4H10 because that was addition reaction in the presence of nickel. This whole process becomes very important for us when we talk about production of margarine. Production of margarines. Actually, when we have those vegetable oils which are generally extracted from sunflower oil or olive oil or soybean oil, we have all these oils contain a good number of carbon-carbon double bond. So these compounds have a structure. I'm not drawing the whole structure for you, but I'm just showing you that these compounds have a lot of carbon-carbon double bonds like these. And you should understand that you only have to focus on the carbons which have carbon-carbon double bond. Inside each vegetable oil, there are so many carbon-carbon double bonds like these. And you should understand that your focus should only be on those carbons which have carbon-carbon double bond. When you pass these vegetable oil structure, this is a structure of a random vegetable oil. When you pass it through a bed of nickel catalyst, at around 200 degrees Celsius and a high pressure, almost a pressure of 70 atmosphere, when you allow that, you get a molecule of margarine, which looks like this. So this molecule has no carbon-carbon double bond, and it has bonded to new hydrogen atoms. Each carbon which had the double bond gets one hydrogen atom each. So vegetable oils are converted into margarine using the presence of nickel catalyst, and you can say hydrogenation reaction. Generally, vegetable oils have low melting point and boiling points, but margarine on the other hand has a higher melting point and boiling point. That is why margarine has a more solid structure compared to a vegetable oil. So in today's video we talked about the addition reaction of hydrogen. We understood that how nickel and 200 degrees are essential to add hydrogen atoms on the carbon of the double bond, to remove the double bond and make an alkane. We looked at few equations and we looked at how vegetable oils are converted into margarine with the help of nickel catalyst. Stay tuned guys, thanks.